Kia ora and welcome to video 20 in the series Agile Algebra. This video is going to be presented by a former student of mine, Caitlin Mitchell. Caitlin, while she was at school, not only was our Dux and an outstanding scholar in Schol Calc, she also got the gold Duke of Edinburgh, was in the first 11 hockey, and did a myriad of other things during her time at MAGS. Definitely made the most of every single opportunity. She's now currently at the University of Canterbury studying maths and physics. Exponential generating functions was our last catch up. We were talking about those and I had absolutely no idea what they were, but she assures me that they're magical, magical like this video. So here are the questions that we're going to go through in this video with Caitlin. There's a couple of proofs. They are algebraic in nature despite the trigonometry. One of them is easier than the other. I quite like her solution for the second one because it was way nicer than the one that I had prepared. So anyways, like normal, pause the video and give these a go and then enjoy the solution that Caitlin runs through with you. All the best.
Hey guys, I'm Caitlin. I was in Mr. Warden's Schol Calc class a few years ago now. So today we'll be proving these identities. They look a bit gross, but the question isn't actually too tricky. We'll just need to use the definitions and then use some algebra to simplify it. Okay, so we get started on the first one. So we'll use the definition first, but we'll be subbing an ln x instead of x into that. Cool, and now we'll use the first and second definitions. So it looks like a bit of a gross fraction, but the 2's will cancel, and we can see that we have e to the ln x, which will just be x because ln x is the inverse of e, so that, and then with the e to the negative ln x, that's just e to the ln x to the power of -1. So just x to the -1, so 1 over x. Cool, so we'll sub all of that in. We get x minus 1 over x all over x plus 1 over x. Okay, and then to simplify that, we'll times top and bottom by x. Okay. X squared minus 1 over x squared plus 1, which is what we wanted. Cool, so that's the first one done. Okay, so we do number 2 now. This one looks maybe even a bit more gross, but again, it's not too bad. Can't even write. Okay, so we'll take hyperbolic sine on both sides. So it's the same as x equals hyperbolic sine of this stuff. Yeah, so when we took hyperbolic sine of both sides, this inverse disappeared. Okay, so we're going to show this. So we'll start with the right hand side because that one's the most messy, so it's going to be easier to simplify it down. So we use the definition for hyperbolic sine. So Okay, and we'll use the same thing as we did before, that ln x is the inverse of e, so it'll just become this. And then for the second part, this, I'm going to use this identity again, so it'll just become 1 over x plus square root x squared plus 1. Cool, and that's all over 2. And we'll multiply top and bottom by this to get rid of the fraction on the top. So get x plus this all squared minus 1 over 2. Yeah, so this is going to be a bit of a pain to expand, but we can just use binomial theorem. So first term squared plus 2 times first term times second term plus the last term squared. So the square root will just disappear. Cool. So putting like terms together. And I forgot this. Just add that in. Nothing happened. Okay, I'm back on track. Okay, so now we just need to factor out a 2 and an x from the top. So 2x times this. And then the 2 is already factored out at the bottom. And look, we have common factors, so we'll just get x, which is what we were trying to show. So we're done.